Alright, so in this session, let's learn about subnet. So what is a subnet? So subnet is the logical partitioning of an IP network into a smaller segments of networks. So let's take an example of a network. So let's draw one network. Let's say let's just say this is a switch, and let's say this is there we go. Let's say that's a router. So we have more switch, more router, more switch, and let's say this is a computer. So this is a computer. Oops. So let's say there we go. There's another one. Oops, the color looks different. Let's just go. Let's say there's one, and let's connect them. Oops. Let's connect this switch to the router. Let's connect this router to this router. Let's connect this router to this switch. Connect this computer with this switch. Let's connect this router with this switch. Let's connect this switch with this computer. Connect this switch with this computer. Alright, so we have, let's call this as switch 1. Let's call this as router 1. Let's call this as router 2. Let's call this as switch 3. No, switch 2. And then this one let's call as switch 3. So these are, let's say, the computers connecting to these switches. Alright, so if this is the case, if you look at this, remember this router is the one that partitions the network. So if that is the case, router 1 partitions the network on this left side, which belongs switch S1, and the router on the other side R2. So if we think and consider router as the one that divides and partitions the network, then we will say how many small segments or small networks are available here. So we can say, let's say this is one network. Okay, let's try to make this don't fill anything, and let's make this Something like this. Okay, so that's one network, and this is another network, and this is the third network. Make it a bit smaller. That's the third network, and there is another network here because router R1 and R2, they are connected and they form another network. So altogether, if you look at this network diagram, there are 4 network segments: 1, 2, 3, and 4. So let's say a primary IP address has been given to us. There we go. And let's say we were given a primary IP address of 192.168. Let's say 20.0/24. So what it means is the network subnet mask is 255.255.255.0. So what does it mean? It means the first 24 bits of this network is the network portion. So if I say what is the mask of this network, then it's 255.255.255.0. So basically that's equivalent of saying /20 and 4, meaning the first 24 bits of the 32-bit IP address. That's what it means. So in decimal, if I represent, it turns out to be 255.255.255.0. So if I convert this into binary, then it will look like 255 means 8 ones, so 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. So that's the 32-bit IP address, and out of this, the first 24 bits, that's what it says here, /20 and 4. So the first 24 bits belong to the network portion. So the first 24 bits belong to the network portion. So 8 plus 8 plus 8, that makes it 24. So 8 plus 8, 16, 16 plus 8, 24. So that's why we say /24. /24 means the first 24 bits of the network IP, of the IP belongs to the network portion. So what about the rest, remaining 8 bits? So that is for the host. So the first 24 bits belongs to the IP, a network portion, and let me select like this. It's easier. So the last 8 bits belongs to the host. So from here, let's see if we can have can we do it like this? Let's see. There we go. So the first 24 bits from here to here, that's the network portion. That's the network. Okay, so the network portion is 24 bits. And the host portion is the remaining host, remaining 8 bits. So remaining 8 bits is the host. We're starting from here, and instead let's change the color to avoid the confusion. No, that's not the one. Where is it? There we go. Is it this one? Yeah. There we go. So the remaining 8 bits is for the host. So when an IP address is given in the format, let's say the primary IP address 192.168.20.0/24, it tells us a lot of story, because it says that the first 24 bits of the 32-bit IP is the network portion. So it means that out of 32, if I remove 24, the remaining 8-bit is for the host portion. So for its network, I will have 2 to the power 8 numbers of possible IP addresses for each of the network. So if we turn or convert into number of usable IP addresses, then it will be 2 to the power, where do we go? To the power, let's say n. So let's say n equal to 8. So to the power 8. So to the power is 56 minus 2. That will give me the total number of usable IP addresses. Why minus 2? Because the first one is reserved for the network address and the last one is reserved for the broadcast. So the rest of the IP address in between them, they are the usable IP addresses. So in this case, 2 to the power 8, that's 256 minus 2, 254. So 254 usable IP addresses are available. Okay, so this is the usable usable IP addresses. Otherwise, the total number of IP address available is 2 to the power 8, so that gives 256. These are the available IP addresses. So it's always 2 less than the available, because the first one is, in terms of usable, 2 less than the available, because the first one is reserved for the network address and the last one is reserved for the broadcast. So here, when we look at this, so we form 4 subnets or 4 different segments in this given network. Segment number 1, segment number 2, segment number 3, and segment number 4. So that's how we calculate, or that's how we will know how many subnets are available. So if we recap, so how do we know how many subnets are available in a given network? Now we have to look at how many routers are available. So router to router, that will be 1 subnet, and router to the rest of the other side of the network, which connects switch and the computer. Let's say this side is one side of the network. Likewise, similarly, this side is another side of a network, and the last 4th one, this is another network. So there are 4 different segments available in this given network. So it means that we will have 4 different subnets in this given network. So when people say subnet, so basically if you look at this, what it means is if this particular computer broadcasts an information, so it will go and limit here at this point or at this port of the router. So it would, this particular port at the end of this router, R1 on this side where I'm pointing, is the default gateway of this subnet. Likewise, if you look at this network, so this router interface here, so that is the exit or the entry point to this network, so we will call that as a default gateway to this network. Similarly, if you look at this third network, this particular port here will be considered as the default gateway, because that is the entry or the exit point of this network. And likewise, if you look at the router, so there is a connection between one side of the network to the other side, so that will also be considered as a separate network. So altogether we have 4 different networks, or 4 different segments or logical partitioning in this given big network. So when you look at this, if we say we have to form a network or subnets, so how do we form the subnet? So this is the given primary IP address, and then we know what is the corresponding mask of this, and we know how many bits belongs to the network, and we also know how many bits belong to the host. So in the next, we will try to find out, or we will try to do the actual subnetting on how